In this question, we're gonna solve the following equation or inequality. So assume that A is the set of integers from 1 to n, okay? So n is in n, the set of positive integers. And also here, x and y are in A. We want to find how many solutions can we find for this inequality. How many x and y can satisfy these ones. Okay, note that we use A inside the absolute value looking to mean the cardinality of A. That means the how many elements or the number of elements in this set A. In this case, it's n. Okay, so our question is, so given that x and y are in A, how many of them can satisfy x is less than or equal to A? So before we do that, we're gonna make this one smaller. So we're gonna minimize or make the problem smaller. We're gonna work on some sub-problem, basically. So let's make A equal to 1, 2, okay? So here, x and y, so x can be 1 or 2, and y can be 1 or 2, but we have x is less than y. Okay, so if we let y equals 2, okay, what are the values of x? So x can be 1 or 2. That means we have 1, 2, or either 2, because x can be 2. Okay, so if we let y equals 1, what can the values of x? Only 1. Okay, note here we have 2 solutions and 1. That means we have 3 solutions. Let's make this one even bigger. Let's take 1, 2, and 3, our set. Okay, in this case, x and y are in this set, so x can be 1, 2, or 3. The same thing for y. So if I take y 3, okay, so y is 3. How many elements can be less than y? So here, 1 is less than 3, 2 is less than 3, 3 is less or equal than 3. Okay, so what are the solutions? So it's 1, 3, 2, 3, 3, 3. If y is 2, what are the values that are less than 2? It's 2 and 1. So we have 1, 2, 2, 2. Now, if y is 1, okay, what are the values? Okay, it is only one value, so we have 1, 1. Okay, so now we clearly see that if we fix the value of y, we can solve this problem by finding all the values that are less than the y. So all the values that are less or equal than y are solutions. Okay, we see the idea, we see the strategy to solving this problem. So if we let y equals n minus 1, okay, what can be the other values? It's n minus 1, and the values of x, I mean, n minus 2, n minus 3, until the last one, which is 1. Okay, so we can count the number of elements that can satisfy this one by just looking, fixing y, and checking the values of x. Okay, so we're gonna do it now in general. So if y is n, okay, if y is n, what are the values of x that are less than n? It's how many 1? It's 1, 2, 3, 4, and up to n. Okay, so how many 1 do we have? We have n elements. If y is n, we have n elements. If y is n minus 1, what? Okay, let's see if we can graph them here on this line. 3, this is n minus 1, this is n. So if y is here, what are the values of x that are less than or equal to this one? All of these, n minus 1, n minus 2, and so we have, if y is n minus 1, we have n minus 1 value. If y is n minus 2, what are the values that are less than or equal to y? So it's from n minus 2 up to 1. So it's n minus 2. If y is 3, how many elements are less than that? Than y? 3. If y is 2, how many elements? 2. If y is 1, as we have seen here, we have only one element. So the number of xy solutions is given by this sum. So it's this sum, 1 plus 2 plus 3 plus n minus 1 plus n. And everyone knows this sum, okay? So this sum is n times n plus 1 over 2. So the number of x and y's, okay? The number of x and y solution of this inequality and belonging to this set is n times n plus 1 over 2. Okay, so this is a simplification of the problem. We could have done it other way, but this is a simpler, elegant solution to this problem. Okay, so we can write it again by saying, okay, let's fix y and change x and quickly now do the solution, but we are not going to do that. So we have to do it step by step and explaining all the process that we do to get to this solution. And this is our solution to this problem. It's very easy and very simple. Thank you very much.